something just changed, and most people have no idea what's coming. For the past decade, humanity detected 3 interstellar objects, 3 visitors from beyond our solar system in 10 years. Oumuamua in 2017, Borisov in 2019, Atlas in 2025, and every single one of them broke the rules. But here's what should terrify and excite you in equal measure. The detection rate is about to explode. The Vera C. Rubin Observatory just became operational, and according to a scientific paper published this week, we're about to go from finding 1 interstellar object per decade to finding 1 every few months. Think about what that means. We're not talking about a modest increase. We're talking about detecting 20 to 30 interstellar objects in the next few years. And if the pattern holds, if they're all as anomalous as the first 3, we're about to face a crisis in our understanding of what's visiting our solar system. Let me tell you why this matters, and why the next 2 years might answer questions humanity has asked for millennia. The Vera C. Rubin Observatory sits in Chile's Atacama Desert, an 8.4-meter telescope with a 3.2 gigapixel camera. That might not mean much to you, so let me put it in perspective. This camera can detect objects as faint as magnitude 24.5, which means it can see things roughly 10 million times fainter than what your naked eye can detect. But here's the revolutionary part. It images the entire visible sky every 3 nights. Every 3 nights. The whole sky, creating a continuous movie of anything that moves. It generates 20 terabytes of data per night. It will catalog 20 billion galaxies and image 17 billion stars in the Milky Way. And critically, it will detect interstellar objects at unprecedented rates. Conservative projections say 1 every few months. Some estimates suggest we could find several per year once the system reaches full capability, from 3 in a decade to potentially dozens in the next few years. Now, here's where this gets deeply unsettling. Every interstellar object we've detected so far has been anomalous, not just unusual, fundamentally strange in ways that challenge our models of natural objects. Oumuamua accelerated without visible outgassing. It tumbled in ways objects shouldn't after billions of years in space. It entered our solar system almost perfectly at rest relative to nearby stars. A kinematic coincidence with odds of 1 in 500. Borisov looked like a normal comet, until we analyzed it. Its carbon monoxide to water ratio was 3 times higher than any solar system comet. It fragmented after perihelion in ways that revealed a pristine composition, unlike anything from our neighborhood. And Atlas? Well, you know Atlas. 9 anomalies, 1 in 10 quadrillion odds, industrial alloy composition, wow signal direction, non-gravitational acceleration, blue color when it should be red, 3 for 3. Every single interstellar visitor has exhibited characteristics that don't fit natural explanations comfortably. So what happens when we find 30 more? The scientific paper, published by Loeb and colleagues, lays out something they call the 6-dimensional scientific revolution. But 2 of those dimensions should make everyone pay attention. Dimension 3, technological relic discovery. The paper officially establishes the Loeb Scale, a framework for evaluating whether interstellar objects might be artificial. It runs from level 0, definitely natural, to level 10, confirmed technology with global impact. Both Oumuamua and Atlas rank at level 4, not conclusive, but significant enough to justify serious investigation with planetary defense resources. The paper states, and I quote, with an estimated 10 to the 22nd power potentially habitable planets in the observable universe, claiming Earth's uniqueness as the sole technological civilization requires far stronger justification than remaining open to evidence of extraterrestrial technology. And then there's Dimension 6, planetary defense. not against natural impacts, but against potential alien technology. The paper explicitly states that detecting confirmed alien technology could justify annual investments at the level of $1 trillion, comparable to global military budgets. Read that again. $1 trillion annually for defense against technological threats arriving on interstellar trajectories. They're not proposing this because it's likely. They're proposing it because if it happens, if even one object proves to be artificial, the implications justify preparation at that scale. Now imagine we start finding one atlas every few months. Imagine 20 new interstellar objects in the next 3 years. Statistical laws suggest some will be even more anomalous than what we've seen. What happens when we find an object with 10 anomalies, 12? What happens when we find one that maneuvers obviously, that releases visible probes, that transmits radio signals? The Rubin Observatory doesn't just increase detection rates, it transforms interstellar object science from case studies to statistical analysis. We'll build a census, a catalog of what's actually traveling through our galaxy. We'll see patterns, size distributions, compositional trends, velocity profiles, and we'll know, definitively, whether objects like Oumuamua and Atlas are rare exceptions or representative samples. Here's the terrifying possibility. What if anomalous objects are the norm? What if natural interstellar objects are actually the minority? And most of what crosses interstellar space is manufactured? The paper notes that civilizations arising just 1 million years earlier in cosmic history would possess million-year technological advantages. They could have explored, seeded, mapped the entire galaxy by now. And we wouldn't know because until this decade, we couldn't detect interstellar visitors at all. The Rubin Observatory changes that. Starting now, we'll see them all, or at least all the ones that reflect enough light. The paper also discusses Dimension 5, dark object detection. Many interstellar visitors might be invisible to optical telescopes, too dark, too fast, or too exotic to reflect sunlight in detectable ways. Gravitational wave observatories can detect these through their mass signatures alone. Primordial black holes, exotic dark matter structures, or objects deliberately designed to avoid optical detection. We're building a detection network that will find both the visible and invisible travelers, creating a complete census of what's actually passing through our solar system. And based on the first 3 detections, we should be very interested in what that census reveals. The next atlas could be detected within months, not years, months. The Rubin Observatory is operational right now, scanning the sky, building its database, searching for anything that moves against the stellar background. When it finds the next one, we'll have detection rates and response capabilities we didn't have for Oumuamua. We can mobilize telescopes globally within hours. We can track trajectories in real time. We might even attempt interception if it's massive and slow enough, but here's the critical question. Are we ready for what we might find? If the pattern continues, if most interstellar objects are anomalous, we'll face a paradigm shift in astronomy and planetary science. We'll have to accept that either natural processes produce far stranger objects than our theories predict, or we're living in a galaxy where artificial objects routinely travel between stars. Both possibilities are revolutionary. Both change everything. The detection rate explosion starts now. The Rubin Observatory is operational. The census is beginning, and within months, we'll find the next one. Stay tuned, because the next interstellar object could be detected any day, and it might be even stranger than Atlas. The age of routine interstellar object discovery has begun, and we're about to learn what's really traveling through our cosmic neighborhood. Subscribe, because when Rubin finds the next one, you'll want to know immediately what it looks like. The mystery is about to multiply.